Hi guys! Today we're going to solve a problem in Chapter 6 of Fluid Mechanics, the fluid flow measurement. The problem is, a water head of 9 meter is flowing through an orifice of 60 millimeters in diameter. The coefficients of discharge and velocity are 0.6 and 0.9 respectively. Calculate the actual discharge through the orifice and determine the actual velocity at vena contraction. The given values are water head is equals to 9 meter, a diameter of 60 millimeter, which we convert it into meters, which it equals to 0.06 meter. A coefficient discharge, which equals to 0.6 cubic meter per second, and the coefficient velocity, which is 0.9 meter per second squared. Before we solve for the actual discharge of the orifice, we should solve for the area of the orifice. So area equals to pi diameter squared over 4. Plug in the values, we have pi 6 squared over 4, so we have 0.000287 meters squared as our area of the orifice. In solving the theoretical discharge, we use the equation theoretical discharge equals the actual area multiplied to the square root of 2 multiplied to acceleration due to gravity times the head. Plug in the values, we have actual discharge equals to 0.002827 meters squared, square root of 2 times 9.81 meter per second squared, multiplied to 9 meter. In total, we have 0.03757 cubic meter per second as our theoretical discharge. And in finding the actual discharge, we use the equation actual discharge equals the actual diameter of orifice multiplied to the theoretical discharge, and plug in the values, we have actual discharge equals to 0.06 meter multiplied to 0.03757 cubic meter per second. So we have 0.0022542 cubic meter per second as our actual discharge. Next, we were going to solve or determine the actual velocity at vena contraction. So we were going to solve first the theoretical velocity with the equation theoretical velocity equals the square root of 2 multiplied to acceleration due to gravity times the head. Plug in the values, we have square root of 2 multiplied to 9.81 meter per second squared multiplied to 9 meter, we have 13.289 meter per second as our theoretical value. Next, we were going to solve for the actual velocity. We use the equation actual velocity equals the coefficient value velocity multiplied to square root of 2 times the acceleration due to gravity times the height. Plug in the value, we have actual velocity equals to 0.9 meter per second times square root of 2 times 9.81 meter per second squared multiplied to 9 meter, and cancel out the units, we have 11.96 meter per second as our actual velocity. So that's all for today. Hope you've learned something and see you in our next video.